Hi, I'm Seong Lee from Computer Vision Lab, Seoul National University. I will introduce DynaVSR, a novel approach for blind video super resolution. It is adaptable to the dynamically varying inputs. This is a joint work with Myung-Sub Choi and Professor Kyung Lee. Blind image super resolution problem requires a downscaling corner estimation process for each input image. However, existing works typically require a lot of seconds for a single image, which makes it computationally infeasible for video applications. The proposed DynaVSR framework makes this process extremely faster by introducing an efficient multi-frame downscaling network (MFDN) and combining it with the baseline video SR model via meta-learning. Previous works in super resolution usually assume a non-blind setting with a fixed bicubic downsampling kernel. However, if a low-resolution image is generated using a different kernel, the SR performance severely deteriorates. Existing blind SR methods estimate the real downscaling kernels well, but most of them run very slowly, since they require heavy optimization at test time. Therefore, these methods are not practically applicable to video SR. Recently, meta-learning techniques are beginning to be integrated into the SR problem for test-time adaptation. In particular, MMR algorithm is used for its generic model agnostic property, which is also used in our framework. To use MMR for SR, we additionally need to prepare the super low resolution SLR image, which is a further downscaled version of the LR input. The training consists of inner and outer loops, where the baseline SR network is adapted using the SLR-LR pairs in the inner loop, and the base parameters themselves are updated using the LR-HR pairs in the outer loop. At test time, only the inner loop is active, and the final HR image is obtained by feeding the LR image to the adapted SR network. However, for blind SR settings, the existing meta-learning-based frameworks still require an off-the-shelf kernel estimation method, which is very time-consuming. In this work, we propose a simple and efficient multi-frame estimation network to accelerate the kernel estimation process. It is composed of 2D and 3D convolution to effectively handle multiple frames. While using MFDN alone may not be able to predict accurate SLR frames, joint adaptation with the SLR model using DynaVSR can solve this issue. Therefore, for the inner loop, we update both MFDN and video SLR network parameters. We first estimate the SLR frames using MFDN and upscale it again to the LR scale using the VSR network. Then the calculated reconstruction loss is backpropagated through both networks. We also add an additional guidance loss to make sure that MFDN is estimating the correct SLR frames. At test time, we only apply the inner loop and use the updated VSR network to obtain the HR frame from the input LR frames. For the outer loop, the base parameters are updated. We use the same reconstruction loss function for both networks, but MFDN is updated using the SLR frames, and the VSR network is updated using the ground truth HR frame. For the experiment, we use various synthetic downscaling kernels to train the framework. This is our full algorithm, and please check our main paper for more detail. We show the quantitative results for various Gaussian kernels. Our DynaVSR can consistently improve the performance of 3 baseline video SR models by a significant margin on all evaluation benchmarks. Compared to blind image SR methods, the final PSNR of EDVR plus DynaVSR shows the state-of-the-art results in most cases. Moreover, note that the computational time for DynaVSR is significantly faster than the other existing blind SR approaches. Our blind kernel estimation process is 60 times faster than kernel GAN and 100 times faster than correction filter algorithm. Qualitative results also demonstrate the superiority of the proposed framework. Even for real-world videos with no ground truth downscaling kernels, DynaVSR is still effective although we only use synthetic training examples. This shows the generalization capability of DynaVSR framework to the videos in real degradations. For more results and extensive ablation studies, please take a look at our main paper. The code and the pre-trained models are available online. Thank you.